Alright, back to another Dungeons and Space Shuttles and Dragons mod pack, whatever it's called. Interesting challenge, autocrafting the Yrdeen fluid bucket with AE2, and I decided to try to use RFTools Control, and of course the Tinkers to alloy it. Now there's an easier way to make this recipe. If we go here to, where is it? Maybe it's the ingot. If you're playing this particular mod pack, you probably just want to make this machine. This recipe is a lot easier than I'm going to show. I just thought it was an interesting puzzle. So coming back here, we can see to make an ingot of Yrdeen, you need 250 crystalline, 1K concrete, and an ingot of this stuff, nitronite. Now, the goal of this video is using AE2 and RFTools Control to figure out this ratio to put it in the Tinker Smeltery. I guess the idea is if someone's trying to do something similar, it kind of gives you a bit of a blueprint on how to, tweak it. So I'm not really going into the scope of how to make, this stuff. This ratio looks pretty straightforward. And, concrete is the mixer from Immersive, and you just melt down gems for that. But first, a demo. So if we middle click on that and we ask for 5 just to prove it doesn't lock up, or hopefully it doesn't. We got the redstone signal, and then we have items getting pushed and alloyed. And we're going to go over the whole setup at some point here. I'll make chapters, but we can see that it just finished. No, it didn't. Those fluids are getting pulled in and pushed, and it's saying done. Now this is kind of unattractive and boring. This is the interesting part. Looks like the craft is done. Now I will talk about it. So the smelter is pretty straightforward. We're using a node to push into the seared drain, and the important thing is filtering the right type. You don't want to pull out, nitronite or concrete or something. So we filter with whatever mod you want, and then we import the craft back into AE2. So like I said, the goal is not how to make the 3 input ingredients. We're using creative tanks here. All you have to do is have, some kind of process that makes these, stores them in a tank, and then you just grab the ratios that you need from them with the computer logic over there. So all we have is a storage bus, and I find it really interesting that AE2 seems to have the fluid storage bus as an item, like it's not an add-on mod. It is part of Applied Energistics 2. But unless I'm missing something obvious, I don't really know how to auto-craft with it. It seems just to be like a storage device. Like if we try to go here and, shift click, we're in processor mode, you would have expected the fluids to pull in. That's how it works on newer versions, but I guess not this version. So that's fine. The other interesting thing is there's no actual recipe. I'm going to break this and hopefully I don't screw it up too bad. So if we go here, we pull this stack out, we can see there's no actual recipe. And I think this is a really underused part of AE2, but this level emitter is the coolest thing. And I wish it didn't turn on right away. If you put this in, and then you put this ingot in, and we're going to leave it in the wrong mode here for just a second, it has no item to craft, right? No recipe, because it's just a status. If you're making this item, let us know. There's a lot of use cases for that. I don't think I've used it, but this is the interesting one. Emit a redstone signal to craft the item. So just by having this set up here, you can't actually do the numbers. You can come over here and suddenly you have the ability to craft. So when I want one of those, it puts a pulse in, and we can see it just poured out and completed it. Now the next setup here. Yeah, so this drive actually isn't even doing anything besides, I guess, storing those items. Okay, so we got the storage bus, we have a basic AE2 system, we have the emitter, and the only other interesting thing, and this doesn't really do anything either. We'll look at that later. This is the other guy that matters, the fluid interface. All you do is you put a bucket of the fluid there, and then it's like a filter, whatever you call it. You set them up, the inputs, and then it can hold 4 buckets of each, which is good that, the recipes don't require more than that. the processor can pull from the fluid interface, and it works really slick like that. You get access to this many fluids. That's pretty cool. And then it immediately, you know, connects to those ones. The processor requires power, as does your AE2 system. And notice my stuff's just kind of sloppily set up and I got creative energy cells. Just quickly looking at the cost of some of these items. They're not super expensive, I don't think, or hopefully they're not, you know, for this stage in the game. Maybe you're playing a different pack, so these recipes might be tweaked. But we got the processor here. Now, this card will actually take this out for now, but really all you have to set up here, let's clear this. Bit of a crash course. You type help, it gives you some information. So if I type, there's a lot going on here. Probably watch like an actual, you know, tutorial on this. I'll just try to give you, you know, my cliff notes. If we do net list, we can see that it knows about a node tinker at this location. So we come here, we have Yrdeen channel and the node tinker. Now, if I was to break this, it's probably going to mess everything up. So hopefully I can fix it. Net list. Let's try to type that right. And net setup. Okay, so it's found nothing. So net list. So everything's gone. Now the node, basically, this guy here, behaves as an extension of the processor. You know, there's only 6 sides to a block, right? So we've got some stuff going on here, but we also need some wireless stuff to happen. That's where the node comes in. And we just tell it, I want to make a random channel called Yrdeen, and Tinker is the name. And this is going to matter a lot, Tinker, because that's what I named a ton of variables in the programmer. So we come back here and type net setup, and it's found it. Net list. Okay, we know it's there, so we clear it. And signal we're not using. There's all kinds of interesting, you know, debug stuff to step through a program. That's kind of advanced, not the scope of this. All you need to make this work for this little program I'm going to show is a basic CPU. They got different types. They're more expensive. But my program's pretty simple, so the basic one will do. And then you need this wireless network card. Wireless network card to talk to that node over there. Without it, you can only use the processor. You can't talk to things. And notice it's a 17 by 17 area around this thing. So that's a pretty huge, you know, what's that, 17 blocks-ish? Probably like 12. So that's fine. And you could put RAM in here. It gives you access to more memory, I think. Like if I put a RAM chip in, notice there's all these extra variables. I've made previous videos on this where I think I used that stuff. It's been a while, been a number of years. And the other thing is the program card that goes in here. You can have multiple programs. I'm only using one. It has to go here because I've allocated these slots for fluid. I lost my train of thought. Where was I? So you click this to set it. So we're going to configure this. Notice I'm going to reference these variables 0, 1, 2, 3 for the, actually, I don't think my program uses 3 anymore. I'm doing it a little different. This is basically nitronite, concrete, and what's the other one? Crystalline. This is for pushing items in. We're not doing that. So that's good enough for now. I haven't tweaked any of these other settings. There's all kinds of stuff, right? And then this is just a tank. These are where the liquids are going to kind of interface with. I'm not even sure if that thing is used, is it? Oh, interesting. It is. That's why I have it there. So we got to set those up again. Interesting. So those tanks just give this thing the ability, the processor, the ability to handle fluids. That's interesting. Okay. So come into the program card. We're going to save it. And notice the shortcuts here. You can, you know, Control A, Control X to cut, and then Control V to paste. I'll probably put a pastebin of this file into, you know, pastebin online so you could copy it and then paste it right in. Of course, the problem is going to be If you change variable names or cardinal directions, north, west, east, south, my program uses that. Like, this is redstone on the east direction. This tank's on the east direction. It's pulling fluids from up. And what else? It's pushing fluids north. I just realized that this part of the program is not actually needed anymore. The redstone on the output part didn't work. So let's cut it. Control X, Control V to paste that. Okay. There's a lot to talk about here. Let's make sure this still works before I go ahead and say it works. We've essentially broke everything and now it's replaced. Okay. Let's ask for 3 of those. So we should end with 50. We got redstone. We got stuff pouring in. Very cool. And potentially the way it's set up, it could, overrun. I tried to, make that not make, 51. Okay. So if I was to tweak the timing, yeah, I guess it made 6. It made twice as many as I asked for technically. You'll hopefully see why when I cover the program. That can be fixed with time delays, I suppose. But this is just kind of a proof of concept. This little comment here. I don't know how much of detail I should go into this thing. It's a pretty confusing or overwhelming opcode program that I spent a lot of time with years ago in Enigmatica 2 Expert. And so it took me probably an hour or two to cobble this together so it worked. So basically, when you pull in an item, you can double click, and I find this really hard. My hands are shaky. And that's the direction the flow is going to go. But notice if we have an evaluation one that has a true or false, if you double click and double click again, you get red and then you get green, and green jumps there. You got to double click a bunch to get red, and I went over it. Yeah, so I find it very hard to actually click on those. So the program starts here. Basically every 2 seconds, it's just going to run indefinitely. It's always going to enter, like when this card is in here, it's basically running. Let's just clear that. It's potentially scanning every 2 seconds according to this. This is kind of an entry of the program, an event. You can have redstone. The problem is this is a redstone, like it latches. Sorry, this is expecting a redstone pulse, like a high and then a low, where this is when it's on, it's constantly on, like it's latching. So I wasn't able to use this. I had to, every 2 seconds, check the redstone on the west side. If you click this, you can type in a node name. If you're dealing with the processor, it's blank, and then west. If I wanted to deal with the smeltery, I would type Tinker, right click to clear. So yeah, processor on the west, which is, minimap, that's west. So you can see it's very easy to make mistakes and a lot of troubleshooting. It's handy to have these messages. I think you see in my program it says done a lot. It's because it's always ending. It's like a complete message. I guess you could always clear these if you didn't want that clutter, but it's good for diagnostics. What else? Oh yeah, these things are interesting too. Like let's say these opcodes are placed in, but you need to get, these are like fillers. They're basically like wires, if you know what I mean. Like let's say I wanted to do some weird pattern, but I didn't want an opcode there. You can use these as wires to connect pieces. They're kind of like blanks. And this one's cool because you can put little comments in there, as you can see here. Getting off on a tangent. Okay, every 2 seconds, check that the AE2 system is, check the status. Is it asking for crafts with the level emitter? And it comes to this evaluation. And notice when I click on this and I hold shift, it doesn't really tell me much. It just tells me how it's configured. It doesn't tell me how it works. You actually got to go here, look for it. And if you hold shift, you can see it checks if the Boolean's true and all kinds of stuff. So we click here, we set it up, and usually it looks something like this. And I guess you could set a constant, but we actually, when there's variables, this gets really in the weeds confusing. But if you go function and then last bool, sometimes there's different options. Looks like there's just one here. But the last bool, what that means is this thing's going to check the condition of the last bool. And since it came from this direction, it's checking what was read. It's kind of how that works. So if the level emitter is false, it's not asking for the autocraft, it comes down here from the red and it terminates on the stop program. And then, 2 seconds later, this will check again. So of course you could tweak this timer, but every 2 seconds we're checking. If the level emitter happens to be on, we test a lock. Now the lock I've named latch, and I use this in 3 spots. I use it there, I use it here, and then I release it. So the lock is really interesting. It prevents every 2 seconds, if it was working through this program, 2 seconds later it would try to do it again, if that makes sense. Like this might take 10 seconds to happen. It doesn't, but let's just say this took 10 seconds to happen. If this is calling for it every 2 seconds, you could see it would just mess up, right? So what we do, if we've decided the level emitter is asking for an autocraft, we evaluate the latch lock. Where is it here? And we test it, we see if it's set, and if it is, we return true. So let's just assume that it's not running, so it's going to return false. So we're going to go this direction, and this is going to evaluate the last Boolean. And actually, you know what? Let's say the AE2 system is already making something. So it's going to say, you know what? This thing is locked. And then it's going to say, okay, it's locked, so it's true. We're going to wait 5 seconds, and then we're going to say locked. It's basically a busy signal. And then 5 seconds later, it's going to test it again. So that's interesting. Now let's say AE2 is free and it's not asking to autocraft. Well, it's going to lock the system because now something's happening. Let's lock it so we're busy. Now what we're going to do is we're going to fetch liquid. Now this is a little confusing. I guess it all kind of is, but, or to me at least. We're fetching liquid versus pushing liquid. Notice the little pictures from the processor. It's pulling from a tank, and then this is a tank pushing to or a processor pushing to a tank. There's again a little story here you can read. But we're looking in the up direction. Again, if this was a node, we could name it like Tinker, but it's the processor, so it's blank, and we go from the up. And some blocks, I guess, have faces that you have to access it from. It doesn't matter, so it's star. So you can imagine too with variables and all that, like you could make some really complex stuff. It'd be super easy to get lost in. That's how that works. So it's pulling from this ME interface, that fluid interface. It's asking for 144 of this type. You can click here with a bucket and set the filter just to make sure you don't grab the wrong thing. And we're going to store that in slot 0. So what's basically happening is the processor is reaching up into the interface, and it doesn't matter where it is in here. Notice it's in this slot, but what it's going to do is it's going to put it into this slot, 0. And the other interesting thing is notice the result. After all that, it actually returns a number of what it grabbed. And so what I decided to do, I don't fully know if I've tested it, but it seems to work, is I do a test, right? If the last number, so it's a function set on last number, and we know that this thing, its last number is going to be what it fetched. So we check that it's 144. That's just a constant that I typed in. And if it's not, wait 5 seconds. We're going to print a message saying, hey, we're looking for this, it's not there. Kind of a diagnostic thing. And then it comes back here and it tries it again, and it'll keep doing that. In theory, I haven't fully tested this all, but I believe it works. It'll keep circling in here until it can get 144 of this in its buffer. And then it comes here and it'll do the same thing. It'll grab 1,000 liquid. We'll put it in slot 1. Again, it'll check And it's same, circular logic. It's really critical to, pay attention to what direction your reds and your greens are putting you. So nitronite, concrete, and liquid cry. So again, the last comparison. So if all of those check and it doesn't get locked up and everything's sitting in these slots right here, it all happens pretty quickly. Then what we do is we use the different direction. We're now pushing liquids instead of fetching. So we are pushing into Tinker. So there's Tinker north, and it's coming from slot 0, which is, remember, right here. And that's all it does, is it pushes the 144, it pushes the 1000. Notice this is slot 1 and slot 2, 250. So notice you don't filter the fluid. You tell it where it is in the processor. Then we wait 1 second. Hopefully the Tinker smeltery, is full of lava, and then it gets made. And then what we do is we release the lock. Really important. We print done, and then we stop the program. Now, I don't think this is really necessary because, 2 seconds later, it's going to call it again. I just put it in there. I don't know if it, matters, right? So I'm sure that's all very confusing, and I'm just realizing this is like a 24-minute video, so that's awful.